We're going to finish up this week's lecture talking about something called periodic trends. And these are ways of using the periodic table to predict or estimate various differences between elements. And the first trend we want to look at is something known as the atomic radius, or the radius of an atom. The radius of an atom is defined as 1/2 the distance between the nuclei in a molecule consisting of two identical atoms joined by a single covalent bond. So if you look across the top here, you see that there are various atoms here that are covalently bound to each other, and the radius is 1/2 the distance between these two nuclei, as shown in the calculation under A. Now, the general trend, there's two general trends that you can predict using the periodic table. And let's look first at a group. Group 1 has H, Li, Na, K, Rb, Cs, and Fr. And you'll notice that the radius increases as you go down the group. And so that's one trend. So if someone were to ask you which is a larger atom, potassium or sodium, you would say that potassium is larger. And then if you look at group 2, if they said which is larger, magnesium or Sr, you would say, magnesium being Mg, then Sr is slightly larger. Now, there's something weird about calcium that we'll talk about in a future talk. The second periodic trend is if you look from left to right, and the easiest place to see this is over on the right side of the table, starting with B and going from B, C, N, O, F, or Al, Si, P, S, and Cl. Both of those, again, P and N being a little strange here, but in general, if you go from left to right, the atomic radius decreases. And so it's decrease from left to right, and it's increase from top to bottom. So that's the first periodic trend. The second periodic trend is something called, well, this actually shows again what happens with the atomic radius. Within each period, okay, so that's from left to right on a horizontal row, the trend of the atomic radius decreases as Z being the atomic number, increases. For example, from K to Kr, which is shown with, it says period 4 transition elements with a circle, from K to Kr, there's a trend of decreasing, okay? Within each group, for example, the alkali metals shown in purple, purple being across the purple colors are difficult for me. Alkali metals, I'm sorry. Purple is Li, Na, K, Rb, and Cs across the top there. You see that the trend of the atomic radius increases as Z increases. You'll see that the increase is more dramatic going down a group than it is going across a period. And you also see that there's the possibility of a few outliers as you go across. For example, there's little bumps up going from K to Kr. The radius for a cation, remember that a cation is an element that loses electrons, shown on the left here, Al versus Al3+. So the radius for a cation is smaller than the parent atom, Al. This is because of the loss of electrons. The radius for an anion, that is something that gains electrons, is larger than the parent due to the gain in those electrons. So let's do these problems, and I won't have to switch to the other notepad in order to show this. See, before I'll give a little space so that you can guess your answer before I tell you the answer. You'll need to look at a periodic table, obviously, in order to do this. So if you look at K and Cs, if you look on your periodic table, K is about 3 down, and CS is at the bottom. So which is larger? We've already talked about this before. We can actually look back here and see that K is over here on the left, modestly to the left. CS is more to the right. So CS is larger. And here it is on the periodic table right here. You can see on the left here, K is in row 4 or period 4. CS is in period 6. So CS is larger than K. K or BR. Now, K and BR are both on the same period, period 4. But remember, as you go from left to right on period 4, that they get smaller. So K should be larger than BR because they're both on the same period. K or K plus. Well, what did we just say in the previous slide? We just said in the previous slide that a cation is always smaller than its associated parent. In this case, the K plus is the cation, and the associated parent is K, so K is larger. Now this is a second trend that we can look at. This trend is called the first ionization energy. The first ionization energy is the amount of energy required to remove the first electron, which is the most loosely bound electron, from an atom, from a gaseous atom, in its ground state. So in its ground state means that it's not ionized. And so you have, if you look, you can see that hydrogen is over here on the left. To remove its first electron takes a certain amount of energy, looks like about 1,300 kilojoules per mole. The next one, helium, is significantly larger to remove it. It's 2,300 kilojoules per mole. Then you drop down to lithium, which is the next one, and it's only 500 kilojoules per mole. Each one of those, since it's the first ionization energy, it's to remove the first ion or first electron. Notice if you go across the bottom here, lithium, sodium, potassium, RBCS. If you look on your periodic table, that's group 1. So as you go down the group, the energy goes down. You see that? As you go down the group, the energy goes down. Also across the top is the noble gases, which are all the way on the right on your periodic table. Helium, neon, argon, krypton, xenon, and radon. Although their energy is quite a bit more than the ones across the bottom, again, as you go down, to remove one electron takes less energy. Now, what about the period? Well, if you look at our example, which was potassium to krypton, that was the last one. As you go from left to right in any particular horizontal row or period, the energy goes up. In general, you'll see there's one outlier after zinc, but in general, to remove one electron as you go across from left to right takes more energy. So within a period, the first electron energy, or the first ionization energy, increases with increasing atomic number. That's what we just said. Down a group, the first ionization energy decreases with increasing atomic number. So let's take a look at this and see what our answers are. We're looking at the same 3 examples as we looked previously. Okay, so which one has the higher first ionization energy, potassium or cesium? Potassium is higher in the periodic group than cesium, and as you go down the periodic group, you get lower first ionization energy, so the potassium will have a higher first ionization energy. Potassium or bromine, as you go from left to right, the ionization energy increases. So bromine has a higher first ionization energy than potassium. This third one's a little tougher. potassium or potassium plus, well, potassium plus has the same arrangement electrically as argon, which is the third element down on the group all the way on the right of your periodic table. And since it's all the way on the right, it has a much higher energy than potassium. So generally, cations have a much higher first ionization energy than their parent.